So we've started looking at functions, and a couple of the examples in the preparatory work had you look at them. But let's take a step back for a minute and think about why we use functions. And it comes down to a number of reasons, but one of the key ones is that they provide a layer of abstraction. Remember, abstraction is one of the computational thinking skills that we've talked about, and functions are a big part of that. So if you think about programming, we're writing really small programs right now. But as they get longer and longer and bigger, it gets much more difficult to manage, to understand, to manage, to fix, to find problems. And so functions, among other things, allow us to chunk the programs into smaller pieces. And then we can write and test and manage each piece in a smaller way. And so that makes it a little bit more manageable. If you think about how a car works, you certainly wouldn't want to have to keep track of every single individual piece without some organizing structure. And functions operate similarly. They allow us to decompose a program into sections or units or modules. We call them functions, just like we do with a car. And similarly with a car, what they allow us to do is provide a programming interface that hides some of the complexity of the code underneath. So just like in a car, you just step on the brake pedal to stop the car. You don't worry about the fact that there's a whole braking system under the hood that takes care of that, right? And functions allow us to similarly do the same thing. Once you've written the function and tested it, you don't have to worry about that piece of code. You just know that you call it. So let's see what a function is in JavaScript. So it's an object that performs a specific calculation or set of instructions. It can take input, like numbers, words, etc., and it potentially returns output, not always. For example, if we think about a function to compute the balance on a bank account after t years from a starting balance b and an annual percentage rate r with interest compounded n times per year, that's sort of a financial function, we can think of that as a bit of a black box. We don't actually need to know how it's computed if we have the function. So the inputs are t, the number of years, b, the initial balance, r, the percentage rate, and n, the number of times interest is compounded per year. The function takes those four parameters as input and it returns an ending balance. So that black box abstraction makes it useful, but we don't need to know how it works, we just need to know that it provides the correct result. So you've already been using functions. We use the prompt function. You will be, or you have been using the console.log function. We've used alert, a few things like that already. And there are a lot of built-in functions. We'll also start defining and creating our own functions. And the form, there's several ways to define a function, but one of the most common ways here is to use this notation where you have the function keyword and function keyword right up here, and then the name of the function that's the name you give it, and then a list of parameters, and then the body of the function, and all that's wrapped inside of a pair of curly braces. So when you call a function, that's when you're invoking it, and you use the you'll see in the code that we use the paren operators. And the function retrieves values via parameters. Those are what goes inside of the parentheses. And it may optionally return a value. Let's look at an example. So here we want to define a function to calculate the cube of a number. So it's just x cubed. If you notice, we give the function the name cube, use the function keyword, give it the name cube. In this case, there's just one parameter, which is the x. And then in the body of the code, we do the computation, x times x times x, and we assign that value to a variable cubed number. And then the last statement that we execute before the function returns is this return statement. So that's how you define it. We call the function in the code by simply giving it the name and then the parens with the number that we want to cube, and that will display a 9 because the function cube of 3, when it's evaluated, because remember that's an expression, when it's evaluated it returns the value 9, which is then passed to the alert function, which will display it to the user. Similarly, we can use the function in an assignment statement. So cube of 3, again, returns 9, and that value of that expression can get assigned to this variable cubed value. Let's look at a couple examples from the code. So in the basic function.js file from the Ducket, we had you I asked you to change that code a little bit, remember? So instead of having the hard-coded message, I asked you to use a prompt to get that message from the user. So there you used the built-in function prompt to get that value, so it's no longer hard-coded. If we look at the longer example at the end of the chapter, the hotel example, we can which I think you looked at already. But if we look specifically at the function offer expires, we can see how that's defined and see its parts. So we see here the function keyword and then the name of the function. And this function takes one parameter, today, which happens to be a date. Inside of the function, it does a bunch of computation, declares some variables, does some computations, computes some stuff, and it eventually creates a message, which is when the offer expires. And then the very last thing the function does before it returns is to return, or as part of the return, is to return that message that it's created. So the function is called with the parameter today. That value of today that is treated as a variable, a local variable within that function, and we use it, for example, here. And then at the very end, it returns the message that it's created. So that's how it's defined. And then a few lines below, it's actually called right here, where we call offer expires with today being a date that was computed by calling a new date function method. So that's how the function gets used there. So let's go back to the PowerPoint for a second here. There's one important thing about functions is the way that variables operate and they're used. It's called the scope of the variable. Variables declared within a function are called local variables, and they're only used in that function. You don't reference those values, those variables, from outside of the function. They're basically created at the point the function is called, and then they are destroyed when the function returns. You can use the same name for variables in different functions because they are actually different variables. So if we go back to the hotel example, these are actually, notice we're calling offer expires here with the variable called today, which is set right here. But the parameter today is actually considered a local variable inside of the function. And so it's actually a separate function. A separate variable, even though they use the same name. We'll see why that's important in a little while. Variables that are declared outside of a function are called global variables, and they can be used anywhere. Now, there's a big caveat there, is that you shouldn't use global variables any more than you have to. So the rule of thumb is limit your global variables. It's not as big a deal right now while we're writing small programs, but as your programs get larger, it can be hard to manage and track all the uses of global variables, and it can lead to unnecessary bugs, among other reasons. Let's look at an example. We're going to switch over to our example, our basic function example, and walk through how to convert that so that we don't use that global variable inside of the update message function. So recall that the update message function right now we see is referencing the MSG variable, which is a global variable, which has been initialized outside of the function at the top of the program. And what we want to do, though, is actually pass this as a parameter to the function. So I'm going to do this a couple ways. I'm going to add a new parameter to that function, and then I'm going to change the function so that it uses that parameter now. So now it's clear that we have two different variables, and the update message function now requires one parameter. And so when we go to call it, we now have to pass that parameter, that argument. So notice that this distinguishes between the caller and the argument that's passed and the called function and how it references the value that gets passed to it. We'll walk through it. Now the code, it still initializes the message MSG variable based on what the user enters. Then it declares the function, and then it calls the function, and notice it passes the value of the MSG variable to the function. When the function gets called, this message variable parameter gets initialized to whatever was passed by the caller. So when it runs, we now reference that as a local variable within the function. So now we have refactored our code, that's a technical term, to modularize it a little bit better by avoiding the use of that global variable.